Hi there, my name is Dimitris Haralambidis, and in this video I will continue my references to the AP's pre-calculus math subject, and more precisely we will work on the subtopic 1.9, which is titled by Rational Functions, Domain and Vertical Asymptotes. So right away from the title you can see that we will worry about two things in this video. First of all, the domain of a rational function, and secondly, its vertical asymptote. Let's take things easy. And let's begin by the domain. We know by now, because we have seen that in earlier videos, that the domain of a function f is the set of all x values for which the function makes sense. Here we care about a rational function, and we know that a rational function is any function of the form p of x over q of x, where p of x and q of x are polynomials. Now, if we try to combine these two things, what a domain is and what a rational function is, we would say that the domain of a rational function is the set of all x values for which that fraction, p of x over q of x, makes sense. Question: when does a fraction make sense? Or let me rephrase that. Are there any values of x that we could use so that a fraction doesn't make sense? I think that the answer should be obvious by now. Any fraction can take any form except from the form at which its denominator is equal to 0. One single thing that can never happen in a fraction is to make its denominator equal to 0. So, in a rational function, I should accept all values of x except from the ones at which denominator becomes 0. So, to find the domain of a rational function, I should take its denominator, make it equal to 0, and then solve it, and then exclude these values. Okay, again, in the denominator of a rational function, I do not want its denominator to become equal to 0. So how can I find the values at which it is not equal to 0? I can start by finding when the denominator equals 0 and then take out these values from out. Let's see the examples. Let's work with them. In A, we have f of x equals x squared plus x over x minus 1. I should ignore the x squared plus x, and I will directly work with the denominator. The denominator, x minus 1, gets to be 0, means that x is equal to 1. So, if we put 1 instead of x, this denominator will become 0. But that's exactly what we do not want. So, the domain of f should be all real numbers except from 1. In B, g of x is x cubed plus x over x squared minus 4x plus 3. I will begin by finding when that denominator equals 0. That's a quadratic. The easiest or the way that always works is through the discriminant formula. A equals 1, B equals -4, C equals 3. The discriminant is B squared minus 4AC, so that should be -4 squared minus 4 times 1 times 3. It's 16 minus 12 is 4. X1, 2 is 4 plus minus square root of B over 2A. So 4 plus minus 2 over 2. 4 plus 2 is 6 over 2, which is 3. 4 minus 2, 2 over 2, which is 1. So for the values of x, 3 and 1, the denominator will become 0. But these are exactly the values that I should exclude from R, which means that the domain of Z should be all real values except from 3 and 1. And finally, let's go to the h of x. H of x is equal to 2x over x cubed minus x squared plus x minus 1. Like before, I should begin by finding out when the denominator, x cubed minus x squared plus x minus 1, is equal to 0. This is a third degree polynomial. Unfortunately, there is not a single methodology. We have some ways of working with this. Hopefully, we wish that we could factorize that. Indeed, although we cannot factorize it by common factor, not all of these terms, x cubed, x squared, x and -1, they do not have anything in common. But then, by going to the next easiest way of factorizing, we can see that we can factorize that by groups. We can group the first two, and we can get that x squared x minus 1 plus x minus 1 equals 0, which means that x minus 1 times x squared plus 1 is 0. And here, by applying the 0 product rule that said that a times b equals 0 if and only if a is 0 or b is 0, we can assume that either x minus 1 is 0, which means that x equals to 1, or x squared plus 1 equals 0, which means that x squared equals -1, which does not have any real solutions. So the only 0, or at least the domain of H, should be all real values except from 1. And there goes the first part of this video, which was dedicated on the domain of a rational function. Once again, the key part of that was take the denominator of the rational function, make that equal to 0, solve this, and then exclude these values. Let's continue with that from R, from the set of real numbers. Let's go now to the second part, which is the part of the vertical asymptote of a rational function. Now, let's begin with what a rational function is. What a vertical asymptote, is. A vertical asymptote, from now on, should be notated by VA, is a perpendicular to the x-axis line, therefore is a line of the form x equals k, at which the graph of a function gets infinitely close, but without ever touching it. With regards to the rational function, to find the vertical asymptote of a rational function, we need to do the following. Take the denominator, just the denominator, make it equal to 0, and solve for x. As easy as that. So, take the denominator, make that equal to 0, and solve for x. Let's see some examples. X squared plus x over x minus 1. To find the vertical asymptote, we should take the denominator, make that 0, and solve for x. X equals 1. That's the vertical asymptote. How would that look alike? Assuming that this is the x-axis and this is the y-axis, x equals 1, assuming that here is 1, would have been this line over there. In B, g of x is x cubed plus x over x squared minus 4x plus 3. Again, in order to find the vertical asymptote, I should take the denominator and make that equal to 0. Previously, we solved that we can do that by the discriminant is 16 minus 12 is 4. x1, 2 is negative b plus minus root of d over 2a, which is 4 plus minus root of 4 over 2, 4 plus minus 2 over 2, 6 over 2, 3, 2 over 2, 1. So here we have 2 vertical asymptotes. There is no restriction on how many vertical asymptotes a graph can have. And finally, in C, we once again use the denominator to make that equal to 0, and we need to solve that. We have solved that before in this video. We will do the grouping factorization plus x minus 1 is 0, which is the same as x minus 1 multiplied by x squared plus 1, which is the same as x minus 1 equals 0 or x squared plus 1 equals 0. From here, only 1. X equals 1, since the x squared equals negative 1 should be rejected. So, to recap everything we just talked about in this video, we are just discussing about rational functions. In order to find not the zeros, the domain of a rational function, we should take its denominator, make that equal to 0, solve for x, and then exclude these solutions from the set of real numbers. On the other hand, in order to find the vertical asymptote of a rational function, we should take the denominator, make that equal to 0, and solve for x. That's all. I hope you understand that clearly. If you have any questions, feel free to leave your comments below. As always, thank you for your time.